My name is Jack Burgess. The Yosemite Lumber Company had several inclines to get logs out of the woods. I will be sharing some photos of the lumber company and the inclines, including some historical movies which I hope you will find interesting. Yosemite Lumber Company was associated with the Yosemite Valley Railroad, which began construction in 1906. The railroad extended from Merced to El Portal at the western boundary of Yosemite National Park. By the time the railroad was under construction, it was realized that finding a lumber company to harvest the timber surrounding El Portal would result in increased freight traffic for the railroad. The Yosemite Lumber Company was formed in 1910 to take advantage of those resources. Show you some of the equipment. This is number one of the 5 shay locomotives they had. One of the 3 truck shays. Climax number 4. Hank Johnson wrote a book about the Yosemite Lumber Company and the Yosemite Valley Railroad back in 1963, and he stated that this locomotive was sent back due to steaming problems. I'm not sure that is correct. It may be that the guys just didn't like it. Maybe they wanted shays and they didn't want a climax, but they did get a climax, but only had it for a month or so. Typical log train in the early days. This is one of my favorite photos of the Yosemite Lumber Company. On a turn, at the very back of the train, you can see a tank car. We'll talk about those in a few minutes. Did you notice anything different in the log cars? Notice they had bulkheads on the end of the cars. And that was because these cars are going to be going down an incline. Here's the problem that they had. The railroad was at an elevation of 1,900 feet, and the timber was 3,100 feet higher, and switchbacks were just not practical in this terrain. The solution was an incline, went straight up the mountain, just under 8,000 feet long. The very top was the steepest at a 78% maximum grade. This is one of the earliest logging inclines in the West Coast. At the very bottom of the photo, that is the railroad yards of the Yosemite Lumber Company. This photo shows the incline under construction. This is actually in a sag. You can see that they actually built one track, one on the right, all the way up to the top, and now are coming back on the second track on the left. Keep in mind that everything had to be built by hand. They did have steam donkeys to assist in pulling loads up, but that was it. This is construction at the very top of the incline. The structure behind these 2 guys that are working on the track was to get the incline cables over the cars as the cars were coming down. The incline also needed to cross the Merced River at the bottom. Here's the unique bridge which crossed the Merced River. Another view of the bridge. This is the sag shown in the photo of the incline under construction. This hold down kept the cable from ending up 250 feet above the tracks in the sag. You can see a car coming down on the 78% grade section of track and the hold down at the bottom of the sag. This view really shows you why they needed that hold down, because that cable would be coming up if they didn't have that. This is the top of the incline. There were 2 loads tracks and 2 empties tracks as shown in that map. And the map is actually a map drawn by the lumber company circa 1910-12, somewhere in there. Another view of the top of the incline. Looking back at the Hoist house in the background. There's a whole line of empty log cars on one of the two empty tracks. This shows the track layout at the bottom of the incline circa 1916. The YV main line is at the bottom. You can see the YV station and their yards, and tracks going up the incline and coming down the incline. The empties went up on the left leg, the loads came down on the right. And what that meant was you always had to have the bulkheads on the downhill side to keep the logs from sliding off. So the cars would go up from the empties track to the top with the bulkheads at the bottom or downhill. And when they came down, they would go down the loads tracks, and that actually turned the log cars around. So the YV built a Y 2 miles west of here to turn all the log cars around again before they got here. Here's a good view of a car coming down the incline. It's loaded, so it's taking the tracks on the west or our right side into the loads tracks. This photo shows a car coming down and another car loaded with ties waiting to go up. The tracks in the center go off to an oil track, which I'll talk about in a minute. Good view of the west leg of the Y with loaded log cars, and those are not train crew members on top of the cars. But I got this photo within the past year, and it was the very first photo I'd ever had of this loads track. And to the left is a YV boxcar, which was being used for section crews. This is looking straight up at the incline. The oil track is right in line with us. What this allowed them to do is take an incline tank car, run it straight down into basically a hole, and there it could be loaded from a tank car up in the yards by gravity. This is the very first log car that was built by Seattle Car and Foundry in 1912, car 801. There were 60 log cars in this order. And notice the bulkhead. I'll be talking about that in a few minutes. It was not the full width of the car and not very high, and that was a problem. Here's how they loaded the cars. They loaded all the logs except one log, chained them down, and then dropped another log on top. And the reason they did that, they did not want to use chain binders like you would use in trucking and so forth much later, because as the cars were going down to the lumber mill, things would settle, and chain binders would get loose as the logs settled. So instead, they chained them as tight as they could, dropped one more log on. As things settled, that log on the top kept tension on the chains. Here are drawings of a log cable and the log bunk. On the left is the cable. The shackles at the bottom were attached under the car to the frame. The wire rope came over, and then they just chained the hook as tight as they could. On the right is a drawing of the log bunk. The blocks are movable. The one on the right would be on the far side of the train when it was at the log pond. In the woods, it would be pulled up tight and hooked in place. The one on the left would be pushed up tight to the logs and hooked in place. This is set up so that when they were at the log pond, the block at the right or the far side could be loosened and the logs would fall off. This photo shows one of the 3 tank cars the Yosemite Lumber Company purchased to haul Bunker C up to the woods for both the chaise and the donkey engines. And it is going to be coupled to an empty log car because these tank cars were not equipped with a draw head in the factory, which they needed to be hauled up by the cable itself. This slide shows the lack of the draw head above the coupler on the right end of the car here. The dome on the car is at the what would be the high end as it's going up the hill, so that fuel would not be coming out of the dome in the 78% grade section at the incline. This photo was taken after the lumber company went out of business. This photo shows a crew loading logs onto the log cars. It also shows the design of the bulkhead, and you can see that it's narrower than the car, but an extension has already been added to the car to get it taller. As you will see, it didn't work out that well. Here's another car. You can see that somebody has dropped a log on top of that extension. Kept it from going through all the way, but it was not what they needed. Here's one of the early cars after they've got rebuilt bulkheads. They're full width now. They're taller than the supports angling up from the coupler. And all of these cars were rebuilt by 1925. This is log car 958 at Incline. This shows the incline about 3/4 of the way down. It was double tracked from this point all the way to the top. And so that meant that when one car is coming down, it would be pulling up another car. So a load would go down and empty would come up. This in the background is where they threw the switch back and forth. There's a little shack there for the person that did this. And it was not a sprung switch. A lot of people think, why didn't they just have a spring switch here and not have somebody stationed there all day, every day, throwing the switch back and forth? I'll show you why. So here's why they couldn't use a sprung switch. On the left-hand side of the drawing is a trip, one trip. The right-hand side is the next trip. So in the first, on the left-hand side, a loaded car is coming down the left track, and the cable is laying on top of the ties as it goes down. So when the next one goes up, it has to go up the left side because that's where the cable is. So that means that each time you alternate back and forth, back and forth. Here's a photo of the fellow that was down at midpoint throwing the switch back and forth. He was a switch tender, and that's all he did. Here's track laying across a new timber bridge. I don't know, but I suspect that when they pulled the track up, they harvested all those logs. Those are some big logs. Here's 3-truck Shay 3 on a similar bridge, but not the same one. Same idea. Another view at the same location. This photo made me think that this bridge could be built really quickly. You have the lumber right there, you have a crane, you drop the logs in place, and you're finished. That is probably the reason they went to this type of bridge. These were probably on spurs going into a logging area that was going to get logged, and then the track and everything removed. The lumber company ran out of timber by 1923. The incline was completely removed at the end of the 1923 logging season. And construction moved 5 miles downriver to what became the station at Incline, and another incline was built. Northside Incline was completed that winter and in operation following spring 1924. Here's the second incline, which went straight up Trumbull Peak. Here's another view of that incline, which is visible in current-day aerial photos, such as Google Maps. You can see the logging incline. There is a road that goes up kind of on the right or east side of the incline. That went up to a mine. The tracks went straight up and then curved around, and at the very top you can see the foundation of the Hoist house. As I mentioned, the tracks went straight up and then curved on a 500-foot radius, a couple hundred feet below the Hoist house. This is, again, Google Maps. You can see the foundation of the Hoist house at the very top and the arrow pointing to the support piers for the rollers on that curve. This is another photo of that incline. You can see it at the very bottom. It had a curve. And on this one, they had one curve, and that worked out well because they did not have to turn the log cars every trip. It was about 8,600 feet long. Grades not as steep as the first incline. Those went to 78% grades. These went to 66% grades. About a 4,000 foot elevation drop. Camp 1 was a half a mile east of the top of the incline. The large structure in the middle of the photo was the engine house. A train of loaded log cars backs through Camp 1, headed toward the top of the incline. This movie was shot in 1939 and shows crotch line loading of log cars. Here's one of the shays taking a long line of loaded cars to the top of the incline. This is from the incline looking back at the engine house at Camp 1. You can see a string of loaded cars there. Looking straight down, the loads came in on what would be our left. The empties were on the right. The next step was getting the logs down to the Yosemite Valley Railroad. This is the inside of the Hoist house. Those drums, to give you an idea, were 13 feet in diameter. If you look in the upper left corner, that is the control stand. The guy that is controlling the operations stands up there. Here's a scale drawing of the Hoist. I found it when I was working on my book on the YV. It was in the collection of Al Rose. And once I found it, I realized I want to build a model of the Hoist house and all the equipment inside. So when I run out of projects, this is one I'll be working on. Another view of the interior of the Hoist house. This is looking toward the top of the incline. So the incline would be out beyond the back wall there. This is the electrical panel in the Hoist house. They had regular brakes on the drums so that they would control the speed of a car being lowered. Even though it's pulling up and empty, it still could take off. So what they did, rather than use friction brakes for every single load that went down, is they changed their electric motors into regenerative braking system and fed that power back into the power company. So they used very little regular braking all the way down. It was all regenerative braking. But in those days, they didn't have a way to get paid by the power company for the power they're giving them, and still had to buy power from the electric company at about $500 a month, which was a lot of money in those days. This is the top of the incline around 1925. In the movie, you saw, I was talking about where the loads tracks and empties tracks were. The loads tracks were up against that hillside. The empties track was on that trestle. So they only had one track for each one as opposed to two like they had on the first incline. Log cars were lowered about every 10 minutes. As mentioned earlier on the first incline, loaded cars went down one track and the next time they went down the other track. Here's the very top of the incline, right where it drops over. Here you can see the diamond that they used to get loaded log cars from one side to the other and get empties from one track to the other back into the empties track. The rollers between the rails spread the load as the loaded cars were going down the incline. If you think about it, that cable starts out with no load on it, and as the car drops over, the load on the cable increases and continually increases. So the design engineer for this actually spaced these rollers out so that each one would slowly take up the load and none of them would get blown out by having too much load. That engineer was actually originally the engineer for the Yosemite Valley Railroad and went on to, took a leave of absence, designed the South Side Incline, the first one we looked at, and designed this one. A photo of 3 very large logs going down the incline. This movie shows the incline in operation. Again, 1939 color. It's all professionally recorded. So this is an empty. It's been lined to the track, going to the empties track. Number of logs on that car as it starts down. See how steep that thing is. Little dust came out. That top log actually slid. There it goes again. Slid forward a little bit. That's why they had the bulkheads. They were at the very bottom of the incline. It's getting ready to go through the curve at the bottom. Now there's a spring switch here which will send this car into the loads track. Here's a car on the curve just below the top of the incline. These were the original rollers and supports. Those older style rollers were replaced sometime after 1925. This is a photo of another car coming down. From the number, I know that it is one of the cars they purchased in 1925, but it also has a little angled brace on the bulkhead that the other cars didn't have. This is Jimmy Mullins. He was the longtime lookout on the curve. He had a phone so that if anything was going wrong, he could call the top of the hoist and have him stop, whatever. So he worked out here. No cell phone, no video games, car coming by every 10 minutes. All he could do was watch every single car, and he probably watched them all the way down the incline. No one ever around, no one to talk to. I don't think he liked being around people because in the winter when the logging companies were shut down, he was the watchman that went from camp to camp during the winter and made sure that the snow didn't build up too high on the structures. Here's a loaded log car passing under a hole down, and if you look at the top of the hole down, you can actually see there's rollers up there. So when the car continues and the cable starts lifting, the wings will get that cable to go right onto the rollers, and the rollers will carry it. Here's a car entering the curve that we saw in the movie, and you'll notice there is a reverse curve behind the car. That was designed so that the cable, as the car gets into the curve, the cable would be in line with the track and the rollers. This is the bottom of the incline. The vertical rollers on the right-hand side of the track kept the cable from cutting into the hillside. The empties track is to the left of the curve, The main line is on the riverside, so the empties track was there. You can see an empty car in the background. It will be going up as soon as the cable is unhooked from this loads. Then another empty would be rolled into the spot and so forth. So this photo looks up the bottom of the incline. You can see the rollers. You can see the cable laying there. Empties track just off the center. And on the extreme right is the main line. So they only had a main line, an empties track, and further behind the photographer are the loads track. This view looks east toward the bottom of the incline. The track on the left is for loads. The other track is the main line. This is the telephone shack at Incline. Jim Law is the first person on the left. I met him back in the 70s. I learned a lot from him about logging operations and so forth. Another photo of Jim Law, this time with a load of sugar pine logs at Incline. You can see how the cable attached to the draw head here. What's missing is a pin that actually goes through. So they pulled the pin on this, ready for this car to be rolled down the loads track. Here's the log train coming in with empties at Incline. So they're letting a empty roll down in position to be hooked up to the cable. Put the pin in place. And up it goes. This view was taken from the top of the tender looking back at the train of empties coming in. It was taken by Bob Bluno, and on all log trains, the head-end brakeman was required to be on the tender at all times, and he loved that job. So coming up, he'd be watching for a derailment or something. Going back with the log cars, he would be watching for some problem, something shifting too much or whatever. If you click on the icon that just appeared in the top right corner of your screen, you can watch a video in which Bob talks about his experiences working on the Yosemite Valley Railroad. The Yosemite Lumber Company had 2 additional inclines besides the 2 that we've already looked at. The area that was going to be logged from Camp 2 at the top of the large incline was at a higher elevation, which required the construction of another incline, this one about 1,600 feet long. It was double track the whole way, and if you look carefully, you can see a loaded log cart coming down and getting ready to pass an empty going up. Here's the top of that incline. Hoist houses in the background. This is the Camp 20 incline. It was unique in that logs were basically in a hole, and so they were harvested, and then loaded cars went up the incline. So it wasn't a steep grade, only a 30% grade, only 1,200 feet long, but I let them log out of this particular area. Here's the hoist at the top of that Camp 20 incline. It was not in operation that long, so everything was kind of temporary as opposed to the other hoist houses. Here's a loaded log car coming up that Camp 20 incline. So we're looking at the Camp 20 incline. This is a view of the machinery at the top. And you'll notice they just had a regular donkey engine pulling these cars up. So this car is going to go down, so they've actually got that cable keeping the car from rolling down until they're ready. So they've unhooked that, signaled the operator that that car can go down now. Here a guy's actually riding, and the photographer is riding that empty down. When the car gets to the top of the incline, they hook another cable on to reposition it later and remove the hoisting cable. Here's fallers dropping a large sugar pine tree. These were the most valuable trees in the forest. They had absolutely no knots the first 30 feet up the tree, and you can see in this one it's even more than 30 feet, it looks like. This was very, very valuable wood. Another nice sugar pine. Here's a couple of high climbers doing their work, rigging up a spar tree. They were the highest paid workers in the forest. This pile of logs to me looks like it was brought in by a high lead setup. Now the problem is how to get them out of this pile and loaded onto log cars. This photo shows a couple spar trees set up for high lead logging. High lead logging was required anytime they were logging Forest Service property. In other words, property owned by the government. They were not allowed to drag fallen trees on the ground. They had to get them up in the air so that they would not damage other growth and so forth. So that's what's going on in this photo. This is a crew of a large yarder that brings logs into a loading location. Here's a yarder that's going to be moved, and so they're slowly pulling it onto a Yosemite Lumber Company flat car. Cat logging was started in 1938, and here's a cat on a log car going up the incline. Caterpillar tractors were used to skid the logs to the loading areas. Here's loading logs with a track crane. Started using trucks to move logs to a rail loading area in 1938. I modeled the Yosemite Valley Railroad in August 1939, and in that month they had about 40 log cars per train for the regular log trains. They came up in the morning with empties, dropped them off, turned, came back, took the loads back down to the mill. In addition, extra trains were run every single day, which were their only regular freight trains, and the westbound extra picked up any additional loaded log cars. So here's a log train headed to the mill at Merced Falls. And coming up is going to be that car right there, which was a log car set up to move food and so forth. This is the mill pond at Merced Falls. That's the lumber mill. It wasn't really a pond. It was actually the Merced River with a dam created by logs chained together to keep the logs from floating downstream. Logs in the pond were moved to the jack slip to be hoisted into the mill. The water is washing off debris, especially any rocks that would damage the saw. Clear sugar pine was used for moldings, so forth. I was in a Yosemite Valley Railroad employee's house up in El Portal one time, and their drain boards were sugar pine because they didn't have formica, they didn't have these other materials, and you don't want to have knots in your drain board where bacteria can collect. So I've made several trips current day to the top of the incline, show you what it looks like before and now. So here's that curve where Jimmy Mullins was stationed. And here's that same spot today. This photo shows how steep the top of the incline actually was. It's much like climbing down stairs. Stairs are about the same grade as the incline, and when you get down there, it's like climbing back up stairs to get back to where you started. Here's looking down on the foundation of the Hoist house. And here's what they would see if they looked up. They are on top of the mountain. I mentioned earlier that I'm modeling both the Yosemite Valley Railroad and Yosemite Lumber Company, and I want to share a few photos of my modeling of the lumber company. So this scene is about 18 inches below the ceiling in my layout room, so it's very difficult to get cameras in there. So these were actually taken when it was, before it was put up there. It shows one of the truck reloads, a high lead operation being set up, and on the right a chaise hauling empty log cars back into the woods. Here train number 8 is leaving Merced Falls with a string of empty log cars. They did this every day of the week except the train was annulled on Sundays. Always like the photo on the left, which shows a conductor standing on top of a caboose signaling the engineer. Because of the curves, they couldn't see somebody on the ground. So that was at Incline. Caboose 17 was the caboose they used on all the log trains. Here's in the bottom right is the same operations on my layout in HO scale. The caboose is scratch built. Here train number 9 heads down the canyon with a couple empty tank cars, a bad ordered log car, and some loaded log cars. This prototype black and white photo inspired me to model it in HO, so I tried to duplicate all the details I could see, such as the hawk that's right at the corner, upper corner of the window has been modeled, the bells above the door, the sign, there's a paper sign above the large sign, and that's used to be white, and over the decades it's gotten kind of black, and there's even a broken batten at the bottom corner of the building itself. So this is the north side incline at Incline on my layout. It's about 6 feet long. It's not as steep as a prototype, about half as steep. If I wanted to model the actual incline, I would need about 1,000 feet of incline. The intention originally was to actually have a visitor during an operating session lower cars down the incline and hook them up and so forth. But I finally realized that would be a very boring job and no one would want to do it. I do have it animated with a motor. I have a model of one of the tank cars that comes down and stops and goes back up and so forth. Okay, this layout photo shows a train rolling through Incline. This is one of my favorite photos, and I was able to Photoshop a view of the canyon in the background and lightened it so it looked like it was a long ways away. So it worked out pretty well. So that's the end of this presentation. I hope you enjoyed it. It was my pleasure to put it together with John's help. If you are interested in seeing more of my layout on the Yosemite Valley Railroad, go to YouTube and search for Jack Burgess, Burgess, and Yosemite Valley Railroad.